Thank you all for joining us today. My name is Vaishali Ghia, and I lead network and network security sales at Amazon Web Services. I am joined here today by Jamie Wenzel, Senior Solution Architect at AWS, and Charlie Wells, the Director of Alliances at Datadog. We have an exciting session for you today on AWS PrivateLink, which enables you to build secure application architecture in AWS cloud and hybrid cloud environments by enabling restricted access and also establishing private connectivity without going over the public internet. We will focus on the customer business challenges, how they map to the AWS PrivateLink use cases and solutions, benefits of PrivateLink in the first part of the session. And then we will launch into the PrivateLink common deployment scenarios and deep dive with Jamie Wenzel. Charlie from Datadog is going to cover key use cases, benefits, and customer wins of AWS PrivateLink and Datadog joint solution. We're going to then wrap it up with Q&A. So as we all know, security and compliance are top of mind for CIOs and CISOs to reduce the business risk and also quickly respond to threats coming from the inside and outside of the organizations. Customers are also looking to restrict application access versus enabling a broader access for the entire virtual private cloud or subnet on AWS. They need that private connectivity between VPCs, and of course, they don't trust the third-party application traffic coming into their VPC and would like to have better visibility into what's coming into their environment. So customers in financial services, healthcare, and government sectors need to adhere to the regulatory measures and achieve compliance as well. Preventing your sensitive data, such as customer records, from traversing the internet helps you maintain the compliance with regulations such as HIPAA, EU and US Privacy Shield, and PCI compliances. Customers also don't want to run their cloud workload traffic over the public internet. They don't want their network, resources, and applications to be reachable over internet, as it is one of the biggest threat vectors. Idea here is that nobody on the internet should reach your service or workloads in the cloud. So now let's review what is PrivateLink and what it does. So PrivateLink combines two cloud constructs. First construct, VPC, which is the private network that can be isolated from internet and other VPCs. And second construct, traditional SaaS operated by third parties, which generally require internet access, but with PrivateLink, you make them accessible in your private network. AWS PrivateLink makes third-party SaaS service an extension of your private network and does it securely by restricting the access. PrivateLink allows applications in customers' VPCs to access a service from another VPC as well securely. So AWS services, SaaS applications, data as a service solutions will be presented as an IP address in customers' VPC, even though they may be hosted in another VPC or AWS account. So this is all made seamless with PrivateLink approach. Traffic is routed through AWS private network and does not travel over the internet, and there are no public IP addresses involved. This is very important for all of us to understand that because we want to make sure that there is no threat vector coming from the internet. All the communication is unidirectional. Users can send requests and receive responses from other services over a PrivateLink connection, but services cannot access any other resources in a user's VPC. So it's a completely restricted access coming from the third party into your environment. And only a consumer can initiate the PrivateLink connection. No third-party SaaS can automatically reach into your private cloud. It is, as I mentioned earlier, restricted access between the user and third-party SaaS to minimize threats coming from the outside of the organization. All private links are mutually initiated to maintain security posture. And not only that, private links are always initiated by the user, and SaaS service owners have control over which applications are shared and which users are allowed access to that application. So let's summarize the key benefits of PrivateLink for you. First one is secure your traffic. Connect your VPCs to services in AWS in a secure and scalable manner with AWS PrivateLink. Network traffic that uses AWS PrivateLink does not traverse the public internet, as I mentioned earlier. And that allows you to reduce the exposure to threat vectors such as brute force or distributed denial of service attacks. Second key benefit is that simplifying the network management. You can connect services across different accounts and Amazon VPCs with no need for firewall rules, path definitions, or route tables. If you have very limited IP space or overlapping IP addresses, which many customers do, with PrivateLink, customers don't have to worry about managing that IP address space at all. We have customers who stamp out hundreds of VPCs with the same overlapping IP address ranges, and it is a huge simplification for them. The third key benefit is accelerate your migration to the cloud. With PrivateLink, you can easily migrate traditional on-prem applications to SaaS offerings hosted in the cloud securely and in a scalable manner. Since your data does not get exposed to the internet where it could be compromised, you can migrate and use more cloud services with the confidence that your traffic remains secure. Also, fourth benefit is important for all of us, reducing cost. PrivateLink can help customers reduce cost, especially when they're accessing services over the internet behind a NAT, network address translation device. So PrivateLink eliminates any unnecessary egress data cost for data transfer out of AWS network, and that also includes for AWS partners. So there is a combined benefit here for an efficient architecture, data transfer, as well as reduction in cost for customers and partners. AWS PrivateLink, since being launched in 2018, has 94 AWS services onboarded as of this month. We encourage CISOs or SecOps or DevSecOps teams to rely on AWS PrivateLink as the new normal way to access all of AWS service APIs, any other SaaS or data as a service offerings, any microservices, or particularly anything behind a load balancer. Our goal is to have every AWS supported over PrivateLink, and it is part of our new service launch requirement going forward. So we want to make sure that from the beginning of that service launch, it is securely available over PrivateLink in a scalable manner across AWS regions. Partners are a very important part of the PrivateLink ecosystem. So we have worked with 450 plus partners to build native PrivateLink integration to simplify and secure access to their services. And we continue to add more. Partners can be part of the PrivateLink Ready program, sponsored by the AWS Partner Network. And benefit for the partners here are easier approval for any customer POC and deployments. As I mentioned earlier, no need to punch any holes in the firewall, no updates to the security group. You can also reduce the cost and making the services available or accessible to on-prem workloads securely. The mechanism that was not there before the PrivateLink was released. And then another benefit for the partner is that they can list their SaaS, software as a service offering, on the AWS marketplace with PrivateLink integration, and also participate in the customer spend with AWS using our private pricing agreement. So there is a key benefit here that we can together solve some of the customer business challenges and accelerate their journey to the cloud together with the partner. There's a very good quote from one of our key partners, Snowflake, here, that it is a missing link in being able to deliver between on-prem to the cloud and SaaS services, all without going over the internet. Also important to note that when third-party SaaS services that process sensitive data, or when customers are concerned about the data security integrity, PrivateLink offers an additional layer of security to manage where the data is flowing, like how our financial services customers use PrivateLink today. We have customers across the board and in different industries. We have seen significant traction within regulated industries like financial services, healthcare, government, etc. And a quick example, a very large US bank customer requires their partners to initiate a private link to securely access bank's applications, resources, and data. So now let's talk about the key private link use cases. It is going to help us address these three key business challenges: how we provide secure access to the AWS services, secure access to the third-party or services or SaaS applications, and of course enabling hybrid cloud. So first use case is secure restricted access to the AWS services, which are outside customers' private network. And these services, as I showed in earlier slides, could be any of those services from the list of 94, such as database, SQS, and Lambda. And as I mentioned, we are continuing to add more and more services. We have some exciting launches coming before end of the year too, so stay tuned for that. The second use case is secure restricted access to customers' own homegrown internal application or third-party SaaS applications such as Datadog, Snowflake, Terraform, which are outside of customers' private network. Many customers build their internal services and share them within their organization. For example, one of our largest customers, they have over 3,000 internal services that are shared over PrivateLink within their organization. And also many customers have a pre-built security rule that they cannot publish internal apps and share across organizations unless they are on AWS PrivateLink. So here we want to make sure that customers where they don't trust their own network and want to enable restricted access, they can use PrivateLink in a secure, scalable manner. The third use case is enabling hybrid cloud. There are two parts to the hybrid cloud use cases. A resource in the on-prem data center that needs to access certain workloads or services or applications in the cloud over our direct connect or IPsec VPN using PrivateLink. Or you could also have legacy apps in the on-premise DC, and you can use PrivateLink to make it accessible from AWS Cloud for your entire organization. So many customer workloads are still on on-prem data centers, and they need to be securely accessed from AWS Cloud using PrivateLink, and we want to make sure that we are enabling that important use case for our customers and partners. So with that, let me hand it over to Jamie to cover some interesting topics on the deployment scenarios and dive deeper into the AWS PrivateLink.
Thank you, Vaishali. My name is James Wenzel. Everybody calls me Jamie. I'm a partner solutions architect with AWS and a networking specialist. And let's dive deep into some AWS PrivateLink use cases. So in this case right here, we're showing the first example of getting access to AWS services from PrivateLink. And there's two different ways to do that. The very first way is an interface. An interface will actually go onto your local VPC with a local IP address. You would simply interact with this interface to gain access to services such as Amazon SQS, Lambda, IoT, and much more. This is one where you have to actively point your workloads or your instances to this interface to gain access. The second type is a gateway interface. This gets you access through the routing table, such as Amazon S3 or DynamoDB. When this is enacted, everything within that VPC will naturally go over the AWS backbone to get to this service, as opposed to going out through the IGW or the public internet. So to note, with both of these access types, the interface type and the gateway type, none of the traffic goes over the internet, and you no longer need to have an IGW or an internet gateway to get access to either of these services. In the next example, we're going to show you how to gain access to third-party apps for SaaS applications. On the left-hand side, we have the ISV, or the provider, and on the right-hand side, we have the consumer. Again, the consumer will go ahead and access the VPC endpoints that are local to their networks to gain access through the AWS backbone to the provider's services. This requires a network load balancer, and the network load balancer will advertise its service, and the consumers will simply consume that service and enact the VPC interface endpoints. One thing to note too within this infrastructure is you'll notice on the ISV side, the IP address of their VPC is a 10/16. And on the consumer side, they also have a 10/16. That's one of the benefits of PrivateLink. It does not require you to have unique IP addresses or unique CIDR blocks for either side. This allows you to consume these services on any VPC without having to worry about IPAM or IP administration. Another example that Vaishali had talked about was how to gain access or how to use a hybrid infrastructure. And there are two ways to do this. So let's say our consumer has something that they have on-prem, maybe a manufacturing plant or something that cannot be moved to the cloud, but needs to consume cloud services. In this example, we have a direct connect or VPN that is accessing a VPC. That VPC will have the VPC endpoint. We need to make sure that that VPC endpoint is routable to all the services on-prem. That is done by configuring your customer-provided equipment, or CPE, to allow that access, as well as to put in the routes within your VPC to actually send traffic back over to your on-premises. Everything else goes as was before. The provider will have the network load balancer, they will advertise the PrivateLink service, and then the VPC endpoints will connect to that service from the consumer account. And then the traffic will simply flow. So on-prem will initiate the connection, go to the VPC endpoint, go to the network load balancer, and then gain access to the services, and then route it all back. Between the AWS customer account and the AWS provider, again, there is no internet access involved here. There's no IGWs. Everything goes over the AWS backbone, as well as the Direct Connect and VPN. The other scenario, remember I said there was two, was that the provider has something that they have on-prem that they need to offer to their cloud customers. They can do this as well by using a network load balancer. The network load balancer must be routable and be able to see the IP addresses of the services they want to present on the cloud through the Direct Connect or VPN. And then they would go ahead and present that information or present that connection to the VPC endpoints for the consumer's accounts. So what are some more advanced uses for AWS PrivateLink? In this example, we have a provider account that is putting a network load balancer in front of an application load balancer. The application load balancer could be doing some form of URL or HTTP rewriting or any type of information that might be needed, or more advanced connections or communications. But the NLB, remember, is a layer 3 or 4, so it's more of a network-only type of pass-through device. So we can combine the more layer 7 ALB, application load balancer, with the layer 3-4 network load balancer and take advantage of both of their benefits. Now the thing about the ALB is that it presents itself, or it presents its IP address information through an endpoint service, which could change. So what we would do is we could do a Lambda that would basically watch for an ALB change and then change the target group within the NLB. Just as before, all of this goes over the AWS backbone. There is no internet connectivity at all for this to change. And when the IP address changes for the NLB, that would not introduce any type of downtime or lag for our customers. The other thing you can also do within this scenario is enable PPv2, or Proxy Protocol version 2. What that will do is it will give the consumer, as well as the NLB and the provider, an idea of where the packets are coming from. This is important if you have multiple customers and you need to set up different billing cycles or different types of identifications for usage, bandwidth, or any of those things. So PPv2 will actually allow you to distinguish all of the different customers coming to your service. Let's take a quick note about the Proxy Protocol version 2. It provides a binary encoding of the Proxy Protocol header. This header is actually additive. It is not a rip and replace. So if that header or if that packet traverses networks and gets other layers put on top of it, you need to make sure that you identify the proxy protocol 2 or version 2 header pieces that you need to identify the unique VPC IDs or accounts. So just be careful when you're going through and stripping off that header to look at the information as to where the packets are coming from, that you're actually keying on the correct information. Let's take a look at the header. When we look at this, the key that you would be most interested in would be the subtype AWS VPC ID key. You can go ahead and search for this, or we actually have a small JavaScript program that will help you with it called ProProt, which is listed here in our GitHub repo. Simply download this and use this in your applications and enable the proxy protocol version 2 on your load balancers, and you can go ahead and consume and find out where these packets are coming from. Here's another example of an advanced use case. If you have something, say, in one region, US East 1, but your customer is not in US East 1, and it is not possible to copy this workload over into EU East West 1, then you can have them connect up via the VPC cross-region peering. So that customer would actually enable a VPC in the same region as where the provider is offering their service, and then set up a cross-region peer, making sure all of the routing is enabled to allow communications to flow. The important thing to note here is that VPC endpoint needs to be able to be routable between EU West 1 and US East 1 for this to take place. Remember that the VPC endpoint is like an ENI, or an elastic network interface, and that elastic network interface gets an IP address, and that IP address, standard routing rules apply, needs to be routable back to the originator or the source that is initiating this connection. In this example here, we're going to extend it even further and allow our consumers to consume a service through a transit gateway. One of the main reasons why you would want to do something like this is that you may not want to have to put in a VPC endpoint in every single one of your VPCs. If you have a transit gateway, and say you have up to 2 to 5,000 VPCs, you wouldn't need to create the overhead and management nightmare of configuring all this. You can actually put it in a single VPC, and again, making sure that VPC is routable through the network to the rest of your VPCs through the transit gateway. The transit gateway routing tables will enable this information to flow through, get to the VPC endpoint's IP address, and then pass that information, as you would normally, through the network load balancer to the provider's resources that you need to access. Let's take a look at PrivateLink a little bit under the hood. So PrivateLink uses our hyperplane-based ENIs. Now, when you initiate a communication with PrivateLink, you will send information to an ENI. Remember that information that you send is a unidirectional flow, which is stateful, meaning that when traffic goes to the ENI or the customer is sending information to that VPC endpoint, it will go through into the provider's account, consume the resources, and it is allowed to come back. But the provider cannot reach through back from their resources into the consumer or customer's account. That's how we have a secure connection. This all happens on our hyperplane, which is software-defined networking that is distributed throughout all of our hardware in all of our regions and all of our AZs. It is what we would call a scalable, highly resilient method of communications. This all happens within software, so all of the hops that you would normally have to deal with if you were setting all of this up in physical hardware, different routers, different switches, things like that, all of that taxing doesn't take place. This throughput or speeds that you get through these ENIs is up to 40 gigabits throughput speeds. And again, they're redundant and scalable because they're software defined. If we have any failures, we have many other machines and many other pieces of software and code that can take over instantaneously. Hyperplane-based ENIs only need to know about flows. They don't have to know about any of the lower or layer 1 or 2 physical connections. And because of this, The transactional states and decisions can be performed, as mentioned here, in tens of microseconds. Now let's talk a little bit about our PrivateLink partners that Vaishali was mentioning earlier. Those partners can offer their services in the AWS Marketplace. You can think of the AWS Marketplace as like an application store. In this application store, SAs such as myself and others curate these things and make sure that all of the services offered do not charge the customer too much money, is HA, is scalable, and is right or will delight our customers in the best possible experience. No public IP addresses are needed at all when we're doing this. Remember, with PrivateLink, the benefit and the joy of that is you do not need to expose those services to the internet. And because of this is like a marketplace or an application like or app store like experience, it's pretty easy to create in the secure endpoints. You can simply click on it and fill out the DNS name, and it makes it quite easy for you to actually facilitate communications, as opposed to having to go through and manually set up everything within the console. Now for providers, if you want to list your services on that marketplace, we have a program for you. It's called the Partner Ready Program. This will allow you to increase your visibility of your applications. When you enroll, you can get your partners can get your solutions featured in the Solutions Finder. It highlights to AWS sales teams that you are actually one of these partners. It gives you better communications. You can get a badge for this. You can promote your products at AWS events such as reInvent or at summits. You can get lead generation created for you. And then also for your teams that are developing these services and features, we offer training. We give you NDA service roadmaps, so letting you know what's coming down the pipe so that you can actually adjust your programs and adjust your workloads to fit and facilitate. We also give you focus groups so that you can actually learn back better what's going on in the industry and have a good idea of where things are going for PrivateLink and for the services that you're enabling, as well as an invitation to our service trainings to learn more about the services that you want to consume. So this gives you a very robust way of getting your programs out there, getting it listed on the marketplace, learning what's coming down the pipe and what's new, and having a better way of communicating and getting feedback from your customers. Now I'm going to hand it over to Charlie at Datadog so that he can explain to you how Datadog uses PrivateLink to enable their services and delight their customers.
Thanks, Jamie. Hi folks, my name is Charlie Wells and I'm responsible for our services, partners, and alliances here at Datadog. And I'm going to spend a few minutes talking a little bit about how our customers have used AWS PrivateLink to connect to our service. But before I do that, I want to give you just a quick overview of who we are and what the problems we're trying to solve with our platform. Datadog is a unified SaaS monitoring and analytics platform for dev, ops, and business teams in the cloud age. We help companies understand the true state of their applications and systems infrastructure, make business decisions, troubleshoot customer issues, and improve the end user's experience. The company was founded in 2010 and we're headquartered in New York City. From the very beginning, the Datadog platform has consistently broken down silos between teams, dev, ops, and even the business side, client side and server side, all to give you a holistic view of your environment so that your teams can troubleshoot and fix issues faster with no context switching. Our operating principle is simple but not simplistic. We sought to create a monitoring platform that is easy to use on a self-service basis, and today we have over 11,500 customers and over 1,400 employees. That's a lot of growth, and it didn't happen by accident. It wasn't coincidental. It happened due to a shift in the market and several changes in the technology industry over the last decade. This is where Datadog can help you. We collect data from all of your servers, containers, applications, and cloud-based services with a single unified agent. That same agent collects metrics. It also collects traces and logs, security signals, and end user experience data. All that data is sent to our SaaS platform, which enables us to do all levels of monitoring listed on this slide. Infrastructure monitoring for your backend servers and cloud-based instances, APM on the application server side, as well as synthetics and real user monitoring for the front end of those application experiences, log management for all front and back end data that allowing you to analyze the details of these issues, and finally network performance to manage and optimize the traffic flow across the entire stack. With everything enabled in one platform, your teams have a single source of truth with zero context switching. Our machine learning and automated correlations help you get insights and take action using all of this data. From tracking SLOs to real-time root cause analysis and integrations with your collaboration and workflow tools, Datadog has you covered. Any stack, any app, at any scale, anywhere. So Datadog provides support for connecting to our customer environments through AWS PrivateLink. Customers can easily configure their Datadog environment to send data through PrivateLink at no additional cost. We see a high degree of interest from our clients in the AWS PrivateLink offering aligned to the use cases mentioned earlier, including hybrid cloud, optimizing cloud spend, and securing data in transit. First, many of our customers are managing complex hybrid on-premise and cloud environments, either as part of cloud migration or as a steady state. In order to mitigate the risk of having data traverse the open internet and simplify the network connectivity between those environments and our platform, these clients are using Datadog with AWS PrivateLink to secure and simplify those network communications. Second, we have customers using Datadog to help them optimize their cloud spend. Our network performance monitor was developed specifically to support this use case and resulted in significant savings for us as well as many of our customers by identifying unnecessary or unknown data egress. And third, we're starting to see more and more customers in regulated industries adopting AWS PrivateLink connectivity to protect sensitive data in transit. This is principally log data that is collected into the log management portion of our solution. So for Datadog, choosing to support PrivateLink was a really easy decision. It provides a great benefit to our customers who use it. Because telemetry in general is very high traffic, the move from classic networking to VPCs hurt a number of customers since networks were no longer reachable within regions. This forced customers to use higher cost external routing. Peering in Datadog saves customers money and allows them to adopt more capabilities within our platform. And in addition, these high compliance environments where routing to the public internet is not allowed also lets us expose our endpoint in each customer VPC and skip this complex routing. One of our proof points is with a large financial institution who uses Datadog's platform to collect infrastructure metrics, application traces, and log data. In these cases, the data collected may be sensitive, and so it was important for this client to minimize the exposure of data in transit, both from cloud environments as well as on-premise environments. By providing support for AWS PrivateLink, Datadog secured a significant expansion with this customer. And the quote from the customer was shown here. Support for AWS PrivateLink was instrumental in making this deal happen. The second and third proof case are really the same around log management. Log management generates an enormous amount of data. These are large apparel companies and large consumer streaming media providers. The volume of data is on the order of several terabytes per day. And at this volume, the egress costs associated with sending that data to Datadog using external networks was simply a non-starter for these customers. Simply by providing direct connect to Datadog via PrivateLink, we significantly reduce the costs for these customers to manage their log data in our platform. So let's take a look at how it works. Part of the beauty of the way that we support AWS PrivateLink is the simplicity of the implementation. This is a very simple diagram showing the general architecture of how AWS PrivateLink is used to connect to Datadog. The overall process consists of configuring an internal endpoint in your VPC that local Datadog agents can send data to. Your VPC endpoint is then peered with the endpoint within Datadog's VPC. So now here's the hard part. How do we get it all to work? Oh, it turns out that it's really super easy. All we need to do is tell the Datadog agent in its configuration file what the PrivateLink endpoint is for each of the following: metrics, logs, processes, and application traces. This is generally done through config management solutions or directly by editing the agent config file. As you can see, providing AWS PrivateLink connectivity to Datadog helps our customers reduce costs, simplify their network, and secure data in transit as it's coming into our platform. It's very easy to get started with Datadog. It's also very easy to implement AWS PrivateLink with our platform. We don't charge for this connectivity, and as you can see, setting the agent configuration is pretty straightforward. With that, I'll hand it back to Jamie.
Thank you, Charlie. Thank you again for showing us what Datadog can do for our customers and how Datadog uses PrivateLink to enable those things for our customers. So what are the next steps? We have a couple of links here, and this slide will be shown to you or given to you after the presentation. But we have the AWS PrivateLink webpage where you can learn more about PrivateLink and how to access it through the console. If you need help building or setting up PrivateLink, we have a blog here on how Goldman Sachs built a cross-account connectivity to their Amazon MSK clusters with PrivateLink. And of course, we have a free course to allow you to go ahead and learn more about how to configure and deploy PrivateLink in your own accounts. So I'd like to say a big thank you to Vaishali and to Charlie for joining me in this presentation. And here are our contacts if you have any information that you need or any questions that you have about PrivateLink. Thanks again for joining us, and we hope to see you soon.